known as Earth's evil twin.
Venus gives us a glimpse into both our past and our future. A past where water formed and perhaps life arose before it did on Earth, and our future where Earth will heat up. So Venus is a fascinating place to look at Earth in a mirror.
The two planets are close in age, size, and makeup. But unlike Earth, Venus evolved into a kind of toxic wasteland. It lost its surface water and became hot enough to melt lead. So what happened? Researchers are hoping to answer that question and whether Venus may have once been brimming with life, with 3 new missions to the hot planet.
They will offer the entire science community the chance to investigate a planet we haven't been to in more than 30 years.
In those 30 years, much of the attention has gone to Mars.
Mars is not like Earth and Venus. Mars is much smaller. It's only about 4/7 the size of Earth. Venus turns out to be the other planet in our solar system, which is the most Earth-like. But yet, a horrible fate has befallen Venus.
Dr. Darby Dyer is among a group of scientists working on the new missions to Venus. She's part of the scientific leadership team for one called Veritas, and it's set to launch at the end of the decade. The spacecraft will take a census of the rock types on Venus. That data is essential for understanding what happened to Venus, and if it hosted life, where it might have been.
Imagine that sometime in the last billion years, Earth was completely covered by basalt. The only thing that would stick up from the basaltic ocean if that happened would be the continents, the high places. So it's sort of like the Noah's Ark on a planet.
Basalt are dark, fine-grained rocks, the kind that line the ocean floors here on Earth. Continents are made up mostly of a different kind of rock called granite, which is lighter. Scientists are interested in granites because they form in the presence of water, a key molecule for life. On Venus, those are the 2 primary rocks that Veritas wants to locate and ID. And it's going to try to do that as it orbits Venus.
It's staggering to me that we know so little about the surface of Venus. And what that means is that anything we find with these missions is going to be really amazing and exciting and first of its kind.
That huge undertaking comes down in part to this sensor. Before launch, Dyer and her collaborators are training the device and its machine learning brains on Earth rocks. Let's take a look at how that process works. First, Dyer collected a diverse set of rocks. Then they were cut and ground. The samples are then sent to a lab at the German Aerospace Center in Berlin. There, researchers heat up the rock chips to more than 800 degrees Fahrenheit in this so-called Venus chamber. It's meant to mimic the surface temperatures on the planet. At such high temperatures, rocks heat up so much that they glow. The kind of light they give off depends on what the rocks are made of. Dark basalts emit more light than lighter granites. That light is captured by the prototype Veritas sensor through a special kind of glass window on the Venus chamber. Eventually, when Veritas reaches Venus, its sensors will scan the planet and compare the new data to rocks it studied here on Earth.
The geological processes act the same, and therefore the rock types, we are fairly confident, are going to be the same.
If Veritas can map out granite formations on Venus, that could help scientists figure out where to send future landers to narrow down the search for signs of life. Habitability, that's the endgame.
Not only do we care about habitability on Earth and Venus, but we also care about the habitability of objects in other solar systems throughout the universe, which are called exoplanets. And if there are other Earth and Venus-like objects out there, then maybe we're not alone. And that's a really important question that we'd really love to understand.